Okay, I guess we'll get started then. So this week I did not think of a lab for you guys.
Yay!
So there'll be no lab. You can, and I told the TA. So there's no lab section today either. Okay.
Yeah.
Thank you.
I wasn't expecting such celebration, but
It's gonna be the
okay. But there's no so no lab assigned this week, and no lab section today. Okay. So is that cool with you guys?
Yeah.
No one's gonna complain that they're not getting the
Damn it.
the education that they've paid for through via lab assignments. Okay. Okay. We got a test coming up on Friday. It's going to cover linear regression and then chapters 11, 12, and 13. Because chapters 11, 12, and 13 are a lot more text heavy. I don't know what just happened there. I think the multiple choice section will be a little longer than the last one or something. Maybe we're this short. There will probably be more definitions and that kind of stuff, or not. I don't know. Whatever those types of questions are. Okay. It should be fair. I would say this time at least read the yellow text in the textbook. If you go through the textbook, some of the text is highlighted yellow. The authors like to ramble on. I guess much like myself, but just the important stuff is in yellow. At least they've done the courtesy of highlighting that. Okay. Well, and then as for calculation type questions, that will all be related to linear regression. That should be no surprise though. Okay, questions, issues? How's everyone doing? Everyone's life is okay? Good? Had a good weekend? More or less? Halloween this Friday? Anybody partying it up? Okay. I'm getting too old for this, you know? And now I have I got a daughter, and she's like 11 months old, so we're like, oh, I guess we have to dress her up, but she can't do anything, right? She just sits there. I don't know what we'll do. You can't trick or treat with an 11-month-old. That's ridiculous. Okay, well anyway, chapter 13. We have to talk about observational studies and experiments. Okay. So I think I've already talked a little bit about observational studies and experiments, but definitely it's worth talking a little bit more in depth on, and the book designates an entire chapter to the difference between observational studies and experiments. This is going on beyond the idea of, or just continuing our series on gathering data. So on Friday we talked about simulations and sample surveys. So simulations was one way to kind of gather data for, I guess, seeing how often random events might happen. We often run simulations if calculating probabilities is too difficult. Then we talked about sample surveys and how to get a representative sample of the population. So often if we want to ask questions, we would take a survey or a sample and ask those people questions. Ideally, we always want our samples to be representative of the population, so we have different methods to help us get representative samples. The simplest, but perhaps practically most difficult, is the simple random sample, and then we also had other methods mentioned, so stratified, cluster, systematic. Regarding observational studies and experiments, this is another way for us to gather data. They gather data in, I guess, different perspectives. So with observational studies, we generally just observe. That's the key idea behind an observational study. We don't tell the people how to live their life. We don't tell them, we don't try to assign the conditions of their life or things like that. We just observe what happens. Okay? So we don't assign conditions. We don't tell people what to do. There are, observational studies can further be broken into two types. We have the retrospective and the prospective observational study. So in a retrospective study, data has already been gathered. So somebody else did an experiment or somebody else did a study, and the data has already been gathered. Or maybe it's not even a study, it's just you're looking at public records, you're looking at birth records or things like that. So the data has already been gathered. And you sift through the data, trying to look for patterns or things that might answer whatever research question that you have. In a prospective study, we come up with the research question first. Find volunteers or people to study. And then we gather data by observing. Okay. The key thing about observational studies, however, is that we didn't assign any of these choices, okay? We don't assign the conditions and we don't tell people what to do. So in the end, we cannot make cause and effect conclusions, okay? this is probably something I'm going to say over and over in this class, is just, when we talked about linear regression and correlation, just because two things are correlated doesn't necessarily mean there's a cause and effect relationship. Just because an observational study shows that there might be some kind of relationship does not necessarily mean that there is a cause and effect relationship. So we cannot make cause and effect conclusions from an observational study. They might point to something, they might reveal that there could be a cause and effect relationship somewhere in there, and that might require further investigation. But from the observational study alone, we cannot make cause and effect conclusions. Okay. On the other hand, we have experiments. And then sometimes to indicate that there's an element of control, we might call these controlled experiments. In experiments, the researchers will assign the conditions of the subjects. Okay, so usually, here we have a research question. Usually something along the lines of, does this thing change this other thing? Okay, so we have a response variable, and we want to know what things might have an effect on the response variable. Okay, so there's a response variable, and then we have treatment variables. And we generally want to know if the treatment variable affects, so this would be a cause and effect relationship, or is connected to, or is related to the response variable. Okay, so what we want to do here is we want to basically isolate the effect of the treatment variable. Okay, so ideally, variable. So we have different levels of the treatment variable. Okay, so we will have different, quote, settings or levels. And with our subjects, we randomly assign the settings. Okay. The settings or levels to our subjects. So the key here is that these subjects do not get to choose what levels they get. Do not choose levels for themselves. So for example, if there's an experimental new drug, we want to know, is this drug effective? Okay. We call for volunteers or participants, but we do not tell them if they are getting the drug or if they're getting a placebo. Okay. They do not get to check. They do not get to choose. So. Experimental drug. They actually put the drug on that. We also, to make our experiment most effective, we want to control as many aspects of variation as practically possible. So, perhaps we are interested, maybe somebody claims that they have a weight loss drug, okay? So we have a new experimental weight loss drug. Now, what are the different things that can affect weight loss? Okay? There's lots of things, okay? The type of food you eat, how much food you eat, how much exercise you have, or how much just physical activity there is, whether there's stress in your life, this and that. There's all sorts of things that can go into someone losing weight, okay? And so in our case, our response variable would be the amount of weight lost. Okay, and the treatment variable would be the drug, whether they get the drug or not, or perhaps there's different dosages of the drug. Okay, I guess the drug, and so the levels could be no drug, low dose, high dose. Whatever levels that we have the drug, okay? But then there's all sorts of other things, what we might call factors. Other factors that can have an effect on the response variable. Okay, so all sorts of other things, perhaps gender plays a role, maybe starting weight, food eaten, both type and quantity. Amount of physical activity, lots of things, okay? Perhaps and what we want to know, we're not really interested in this other stuff. We know how much food you eat, affects your weight loss. We know how much physical activity affects your weight loss. And we suspect that these things might also be related depending on, whatever, maybe the mechanism of the drug. We don't know, okay? What we really want to know is whether this makes a difference, okay? So ideally, we can, control all of this stuff. We can say, okay, everybody is going to have the same diet. Everyone's going to have the same amount of physical activity, okay? And then, if, let's say we were able to control all of those things, then we could say, we had, all the people in this group, or all the people had the same diet, all the people had the same amount of physical activity, and the only difference between this group of people, and this group of people was whether they got the drug, low dose, high dose, or no amount of the drug. Okay? And then if we see a difference between the three groups, then we can attribute that difference to the fact that they had different amounts of the drug. But of course, probably with humans or people, we cannot control as many of these aspects of their life as we'd like, and so we have to accept that there's going to be a large amount of variation between the groups. Okay. Let's say if we could, we would have everyone eat the same food, and have the same amount of physical activity. And the only difference between the different groups of people would be the levels of the drug. Okay. At the end of the study, any difference observed between the groups could be attributed to the different levels of the drug. Okay. But in real life situations that might not be possible, and so we have to work around that. And that's why we use random assignment. And by doing random assignment, we're hoping that the different groups, by random chance, will end up having similar compositions of different genders and different eating habits and different exercise habits. Okay. Through random assignment, we're hoping that the different types of people that we see here get kind of equally dispersed through the different groups. So even though complete control may not be possible, we hope that through random assignment, the different quote-unquote types of people. More or less be equally distributed. Among the treatments. When we do an experiment, we also want to make sure that we have multiple participants, and we have multiple participants for each treatment. Okay, so this is the idea of replication. So we have multiple participants for each treatment or treatment combination. So for example, in this example where we just only have 3 treatment levels, whether you got the drug, low dose, high dose, or no dosage of the drug, there's only three treatments. So you would need at least 6 volunteers, so you can have at least 2 for each treatment level. In more complicated experiments, there might be several treatment variables that you're interested in. Okay, so you might want to know, okay, maybe we have 3 levels of some weight loss drug that you're taking, but then we also want to know, I don't know, if drinking a lot of water during the phase makes a difference. Okay, so we might have people drink different amounts of water. We say, you guys have to drink 1 quart of water a day, and you guys have to drink half a gallon of water a day, or something, I don't know. We have different levels of water consumption. And then so if you have 2 different levels of water consumption, 3 different levels of the drug, you would have a total of 6 different treatment combinations. Okay? So you have 6 different treatments, and then you want to make sure you have more than 1 participant for each treatment combination. Okay? And the more, generally, the better. Because if you only have 1 person per treatment, you don't know if the result that you see related to that treatment, or the result that you see from that treatment is related to the treatment, or just the fact that this person is different from everyone else. Okay? Because there's individual differences between people. There always will be. And so perhaps you see high dosage with lots of water consumption resulted in a huge amount of weight loss. You don't know if that huge amount of weight loss is related to the treatment itself, or just the fact that this person is unique. So you want to have multiple people per treatment, and so maybe you assigned 3 people to that treatment, the high dosage and the large amount of water, and maybe all 3 people showed a large amount of weight loss. Then you can say, okay, probably all 3 people are not just these freak cases, but maybe this treatment combination actually has a significant role. Okay, so we must have multiple participants for each treatment, Otherwise, if there's only one person assigned to a treatment, we will not know if the result is due to the treatment or this person's unique attributes. And then another aspect of experimental design is blocking. Okay? Blocking is a way for our analysis to take into account those other factors that affect the response variable that might be out of our control. Okay? So one way to handle that is through random assignment. Another way, if you're not comfortable with random assignment alone, blocking kind of ensures another level of, I don't know, what's the word I'm looking for? Assigning the, or I guess leveling out the playing field. Okay, so for example, if we're doing this weight loss experiment with some new drug, okay? Let's say you suspect gender is related, will play a role in the amount of people, the amount of weight people lose, okay? If you so, perhaps you know that the mechanism of the drug works through something hormonally related, okay? And therefore, probably gender is going to play an effect. Now, if you just did random assignment, from random assignment, it's very possible that the group that gets no drug ends up being mostly male. And the group that gets high levels of the drug ends up being mostly female. Okay? From random assignment, something like that could happen. And therefore, at the end of the experiment, maybe you find that the group that's high dosage of the drug, but also mostly female, had a significant amount of weight loss versus the group that had no drug, but was also mostly male. If that happens, you don't know if the high amount of weight loss is because the group was female or if it was because of the large dosage of the drug. Okay? And so what blocking would do is it would require that each treatment group has the same amount of males and same amount of females. Okay? Maybe you just, from the number of volunteers, maybe you get more female volunteers than male volunteers, but you would just make sure that each, for the blocking variable, the 3 different treatments, or just all of your different treatments, look as similar as possible regarding this blocking variable. Okay? So blocking allows us to account for different variables that are out of our control that we suspect might play a role in our response variable. Okay? So it allows us to account for other variables that can affect response. So instead of just leaving it to random chance, random assignment to, quote, even out the groups, we might use blocking to, quote, force the different treatment groups to be somewhat similar. Does that make sense regarding the blocking? Okay. At the end of the experiment, there's this idea of a difference being observed being statistically significant. Okay, so are our results statistically significant? Okay, and the idea here is that, sure, maybe group, the no drug group has average weight loss of 2 pounds, and the low drug group has average weight loss of 3 pounds, and high drug group has average weight loss of 4 pounds. I don't know. This is after 2 weeks of using the drug. Who knows? Okay. Are these differences, the fact that this only had a 2-pound weight loss and this had a 4-pound weight loss, is that a significant difference, or is it small? Okay? So at this point, we cannot answer the question without knowing how much spread or how much variation exists within the groups. Okay? So whether or not the difference in average weight net loss is significant or not, whether the differences in average weight loss is significant or not depends on the variation within the groups. Okay. So if every single person in the no drug group lost exactly 2 pounds, every single person in the low drug group lost exactly 3 pounds, and every single person in the high drug group lost exactly 4 pounds, with no variation between individuals in the amount of weight they've lost, then these would definitely be significant, okay? The drug somehow works in making people lose exactly 4 pounds and these people lose exactly 3 pounds. Something amazing is going on. On the other hand, if we look at people in the no drug group, and we see that they've lost anywhere between 0 and 10 pounds, where things around 2 pounds is most common, and we look at the high drug group and we see people losing weight, again, also between 0 and 10 pounds, but just from maybe a different group of people, the average turned out to be 4 pounds, what we see there, what could be going on there is just that the people, everybody is different, and so there's just natural variation existing between participants, and so the difference that we observe here could be a result of just the natural variation between individuals. Okay, so if there is a large amount of spread within the groups, amount of spread or variation within a group, the differences observed could be a result, could be simply a result of the people who are randomly assigned to the group. Just to further illustrate that, let's say, for example, I had each of you toss a coin, and I said, if the coin lands heads for you, you are going to be in the heads group, and if the coin lands tails, you are in the tails group. If I say, okay, everybody tell me how tall you are, and we take the average height of the heads group and the average height of the tails group, the two average heights will not be exactly the same. There might even be, a sizable difference between the average heights of the heads group and the average heights of the tails group, okay? But we know that the difference between the average heights of the two groups is merely a result of the random assignment. And it's not anything to say that people who are taller have a higher likelihood of flipping heads and people who are shorter have a higher likelihood of flipping tails. We know that's not the case. But we're not going to see exactly the same heights, same average heights of the two groups. We know that any difference that we observe between the two groups is merely a result of random chance, okay, or the random assignment. The same thing could be going on when you do an experiment with different levels of the drug or different levels of whatever you're doing. The result, the differences between the groups could be a result of just the random assignment, or it could actually be associated to the different treatment levels. Okay, and so we have to look at the variation within the groups to get an idea of whether it is a difference between the treatment levels or the groups themselves. Okay, I got like 5 minutes. Okay, so just a couple more notes about experiments. Sorry, today is a text-heavy day. With experiments, we generally, our participants are generally not a random sample. Rarely do we have experiments where we have truly random samples of people that will be representative of the population. Okay, so participants for an experiment are very rarely random samples. Okay, so when you get the results of an experiment, they may not necessarily you might not necessarily be able to apply or generalize them to the population, okay? What we're hoping for, though, is that we can say, you know, we have no reason to believe that our participants are not representative of the population, okay? But there is an inherent limitation that can be of the conclusions that can be drawn from an experiment. Okay, the random aspect in an experiment is in the random assignment of the treatments. Okay.